continue. Okay, so question. Can hydrochloric acid be safely stored in a copper container? So what do I do here? I look at the...
شوف إذا continuously.
Okay, so what I do is get the E for the copper. Okay, so that's the first thing. I go ahead and I try to get the E of the copper, or they give me, of course, نحن outside برا بيعطوكم تيبل وانتم بدكم تجيبوا الاي نودز. هلا بالجامعه اللبنانيه لا بيعطوكم هن نفسهم الاي نودز that you are going to use. It's a bit easier. سهلين عليكم. Okay. But if you have a big table where you have different E node values, you have to go and pick up the E node that you need. So we need the E node for copper because I have a copper container. Okay, so I get the E node for copper. And we're reacting it somehow, or want to see if there's a reaction with HCl. In other words, I have H plus ions and I have Cl minus ions in the solution. So I look at any of the electrodes that somehow have Cl minus. We have this chlorine electrode. We have also H plus مع oxygen, which is right here as a reaction. Done. And what we do is we put them on an E node scale. So بيصير عندي هون Cl2 مع Cl minus. بيكون عندنا هون H plus with oxygen. ما بنحط electrons typically when we're doing this, and this is going to H2O. And we have the copper 2 plus. Okay, that's the, the E nodes if I had numbers. So that's my E node scale. All right, شايفينه ولا أسود is not the best color, but anyhow. So we have Cl minus in solution, we have H plus in solution, and we have a copper solid container. Clear? What can react with what? If I have Cl minus, it cannot react with a copper, so they're on the same side. If they're on the same side, there's no reaction between them. Okay, and so both the copper and the Cl are reductants. I don't like it reducing. Are reductants. They're on this side. Okay, so they're the reductant part of the couple. We want to call them reducing agent. Again, there's only one possible reducing agent for the overall reaction. So we can't react them with each other. But what about the H plus in the solution? Well, the H plus, again, it's only H plus water that can possibly react. So possibly the H plus can have a reaction with the copper. That is a possibility, but then definitely I need an oxygen. And when we say we're in a container, usually containers that have HCl, and if I put them in a copper container, هون عندي copper, containers, when we put something inside, we deoxygenate. We don't leave oxygen in. When we put something, we put it not oxygenated, and we remove all the oxygen, then we close the container. So ما في oxygen, ولأنه ما في oxygen, there isn't this possibility of this reaction to occur. So it's not even a possibility. Okay, and all equations, if you see the air's H plus, it's only H plus in the presence of oxygen, that I have equations with it, or some other compound that definitely I'm not adding. Are we clear? So therefore I cannot, and indeed we can put it in such a container, so it's safe. Now, one of the things, I have also H plus here going to hydrogen gas. So the HCl doesn't affect. What about the this guy, this 2H plus with the copper? Now it can go because there's no oxygen. There's only a need for H plus, but it's in the anti-gamma. It's on the bottom here. And so there is no net real reaction between them. And that reaction is not spontaneous. So hydrochloric acid can be stored in a copper container. Okay, so can one store 1 molar copper sulfate in a nickel vessel? Copper sulfate in a nickel solid vessel. And so what we do is, again, بنروح على الcouples. هيدي copper sulfate يعني copper 2 plus. Eventually, we're going to see, oops. بنحط the nickel and the copper on the E-node diagram. Okay. Again, we're assuming here that everything is in standard state. وعطونا ال-E-node للnickel وال-E-node للcopper. E-node للnickel هي so هون عنا nickel 2 plus. Again, the more oxidized form, the more positive goes here, the more neutral or negative goes there. Nickel 2 plus nickel, so هون ايش عنا minus 0.25. Here we have a plus 0.34. Here's my copper. This is copper 2 plus. Okay. So can copper sulfate, can one store copper sulfate in the nickel solid container? You tell me.
No, because there's going to be a spontaneous reaction taking place.
There will be a spontaneous reaction taking place. It's automatic, okay? And the reaction, the E cell, will be cathode minus anode. This is going to be what? The reduction half reaction. Because it has a higher E naught, this will undergo oxidation, or it will want to undergo oxidation. This is my oxidizing agent. And the nickel will be my reducing agent. Are we clear? If I want the overall reaction, this would be it. And that's not the point. The point is, no, I cannot store copper with the nickel because the reaction is spontaneous. And that's all. Okay. Predict what will happen to molecular bromine is added to a solution containing NaCl and NaI. Okay, assuming everything is under standard states. And they gave us the E nodes of the chlorine ion with Cl, the Br minus ion with the Br, and the iodine with I minus. ملاحظين كل المينسز on this side. So actually this, if I write him, this will be Cl2 على Cl minus as a couple, ox على red. Great. So what do I want to? It's the Br2. So this is the Br2. Will he react with Cl minus and or iodine? Look at these. They're already put in an E node. يعني الhigher is upwards. So I don't have to redraw anything. خلاص هحط line هون ال E nodes. هيدا ال Br2. هون Cl minus وهون iodine. Can this Br2 react with Cl minus? can he react with iodine? Who will he react with spontaneously? We're going to look at the gamma or diagonal rules. So diagonal down or gamma rule. Okay. The Br2 will react with the I minus, but not with the Cl minus. What do we say? What type of reaction do we say Br2 reacts with iodine? What is the Br2 going to do to iodine?
will oxidize.
Br2 will undergo reduction.
Okay, it will undergo reduction, but it's the oxidizing agent, so it will oxidize the I minus, which will undergo oxidation then. But what's the Br2 doing? It's oxidizing I minus. It's the oxidizing agent. It will not oxidize Cl.
دكتور why ما في يعمل oxidize the Cl minus?
Anti-gamma. Br مع Cl is with the diagonal rule or the gamma. This is anti-gamma. طالع طلوع هيك.
Okay.
Always the one on the left, the oxidizing agent can only react with something on the bottom of him to the right. هيك حكينا فيها هون. عيدة. Always, the oxidizing agent can react with anything below him on the right-hand side, nothing above him. Okay, so, and yes, for example, Fe2 is the oxidizing agent and it can oxidize any of these guys. Rubidium on the lowest is the greatest reducing agent, and it can reduce anything on the left-hand side above him, because then there's a gamma reaction like that. Okay, Mai?
Yes.
Okay. Also here there's gamma. In the opposite direction, there will be no reaction. Here, magnesium can oxidize calcium, spontaneous, gamma or diagonally down. Okay, diagonal, I can have a diagonal going like that. Here, magnesium and manganese, I'm going diagonally upwards. Okay, from the oxidizing agent to the reducing agent, diagonally downwards or anti-gamma. Gamma, anti-gamma. Okay. Here?
Yes.
Okay, so at this point, we have completed part 5, which is electromotive force and standard potential, and we can start doing the problem sets for that section. Now I want to continue with the next section because it is very related, without doing necessarily the problem sets yet. Okay,